Hi guys, we're picking up our homework for chapter 15 at question 5, where I'm asking you, what is the deadweight welfare loss in dollars when this market operates at the free market equilibrium, where marginal social benefit is greater than marginal social cost? Explain how you know. Okay, so let's go look at our graph and we'll figure this out. So at this point right here, at the market, at the free market output at 30,000, you can see that the marginal social benefit is greater than the marginal social cost. So this is where this market would operate if it was just left alone, the free market. Now, the deadweight welfare loss is this triangle right here between where they're operating and where the optimum level of output is, where marginal social benefit right here equals marginal social cost. So we're defining this triangle right here. So we just simply need to know what these numbers are, and we can see that the base of this triangle is 30,000 to 35,000. So the base is 5,000, and the height here is 7,000 up to 10 right here. So the height here is 3,000. So as you should know, the formula to compute the area of a triangle is 1/2 base times the height. So that will be 1/2 times 5,000 times 3,000, and the answer would be in dollars. So let me jump to the answers, and we'll look at that in writing, actually. We'll look at how that works out. So I've got it all explained. I've explained it all here, just like I just explained it. So we just simply take the area of the triangle equals 1/2 base times height. So this is 1/2 times 5,000 times $3,000, which is the difference between 10 and 7,000. And if I did this correctly with my calculator, it ends up being a deadweight welfare loss if we operate at the free market equilibrium of 7,500,000. Okay. So now we're going to assume that the government is concerned about this deadweight welfare loss and wants to close that gap. So they're going to pay a subsidy that brings the level of output up to the socially optimum level of 35,000 workers. What is the dollar amount of the government subsidy? Explain how you know. Well, we just computed the deadweight loss in question 5, and we let me jump back over here. And we observed that the difference between the marginal private benefit right here and the marginal social benefit up here is $3,000. This is 10, this is 7, so the difference is 3,000. So the government subsidy, in order to bring the output up to 35,000, would need to be $3,000. Okay, so we're going to fill in these dollar amounts for S2 or the supply curve, or the marginal, or we just call it the supply curve with the government subsidy. So we're going to do that in our table right now. So in order to do that, we need to come back over here, and we need to look at this. That's the wrong one. That's the one I've already done. Let's go to the one we haven't done. which is, I think, here. Yeah. Actually, no, it's already in here. Okay. It's already in here. And I guess I had that in there in the one that I sent to you guys. And I probably shouldn't have. But anyway, I'll have to check on that. If it's already in there, fine. But if it isn't in there, you just simply need to... no. Wow. It's not in there. This is where we are, right here. Okay? We've already done that one. Wow, what am I thinking? We need to fill this out. Sorry, guys. So we need to fill out the supply curve with the government subsidy. Okay, so now what you need to think about here is if the government is going to pay a $3,000 subsidy, that is a subtraction from the cost. So we need to simply take this marginal private cost curve, or this supply curve right here, and we're going to subtract from it the subsidy. So we're going to get a lower curve down here. Okay, so we just simply need to click in cell E6 and then come up here and type in equals, and then take the amount for the marginal private cost here and subtract from it 3,000, 3000, okay? And then enter. And that's going to give us, and then just get our black cross here and drag it, and we'll get all of our amounts here. And then I believe it's asking us, I'm pretty sure it's asking us, I'm asking anyway, to plot it, right? Let's see. Yes, plot it. So we need to plot it. So we're going to come back over here, and we're going to add this, right? So we're going to select data, and we're going to, actually, no, we're not going to do that. Cancel. I'm getting in a hurry here. Select data, add. Yes, add. Then we come here, and we select our series name, and then we select our grid below series values. And once again, make sure you take every cell in the column, every row. Okay, so we're going to drag all that. And we're going to go down arrow, okay, and that puts it right there. Okay, so that's in there. All right, now, what's next? So now I'm asking you, what is the new market equilibrium output and price with the government subsidy? Explain how you know. Okay, well, it's going to be where the new supply S2 crosses the private demand right here. So now we are at a new output, and we're our socially optimum output of 35,000 at a lower price of 5,000 right here. Okay? So we're going to train more workers at a lower price. Let's just jump back over to our answers and make sure I didn't say that wrong. I don't think I did. Nope. Yeah. Right here, yeah. I'm trying to figure out where exactly I am here. Okay, we're answering number. Let's see, where's number 7, right? Yeah, 7. Wow, sorry about that, guys. Now right here. Okay, yeah, right here. Okay, this is where the new supply curve equals marginal private benefit. Okay, let's keep going here. So number 8, how much of the subsidy helps the consumer by lowering the price of the retraining program, and explain how you know. Well, if you remember, the subsidy was $3,000, so the price has come down from the market price of $7,000 right here to the price after the subsidy of $5,000. Because and you can see here, this is where this is the market equilibrium here, right? And this is the equilibrium with subsidy right here, okay? which means the consumers, the workers who are enrolling in this program are saving $2,000. Okay. Now, the next question is fairly easy, since we know that the total subsidy was $3,000 and $2,000 was in lowering the price for the workers, so the other $1,000 has to have helped the producers. Okay, but that's just part of it, and I want you to also understand that yes, $1,000 of the subsidy benefits the producers, because the difference between the marginal private cost at the socially optimum output of $35,000 and the marginal private cost at the free market output is $1,000. So that's what you really look at, the difference between the marginal private cost at the socially optimum output compared to the marginal private cost at the market output here. So let's just look at our graph again so we can see that. Okay, so let's jump back over here, and we're talking about this the blue line, the blue curve here, the marginal private cost at producing 30,000 is 7,000, and to produce 35,000 it is 1,000 more. So they're saving this with this subsidy, and they're producing here, okay, because their cost would be higher, but it's not, okay, because of the subsidy. So that's number 8. Let's go back over to number 9. Whoops, number 9, the question. Actually, I answered that, right? Yeah. So the last one here is we want to look at one more thing. I want you to see how the elasticity of the demand curve determines how effective the government subsidy actually is. And if you look at your graph, so I'm asking you to plot the more elastic demand curve on your graph. Okay, and I think it's already in there. Let's just make sure. Okay, let's go back. And it's right here. Okay, so this is the more elastic marginal private benefit, and we just want to compare. So we're going to add that. So we're going to come here, select data, click on add. More inelastic. This is going to be steeper, more inelastic. And then we're going to click on our grid right here, and we're going to once again make sure you select all the rows of the column, all of them, okay? And then come down and go okay, okay. And now we can see a different demand, very much more inelastic than this one right here, right? Then our marginal private benefit right here is fairly elastic. This is relatively inelastic. Now, what does that change? Okay, well, the question we're asking and trying to answer is, if private demand or marginal private benefit is more inelastic, is the government subsidy more or less effective? Explain how you know. Well, if we look at the result right here, we can see that even with the subsidy, if this is the demand, our output would be slightly lower price from here, right? But our output would be far below the socially optimum. So if the demand curve is very inelastic, then the government subsidy of $3,000 would be far less effective. It would only gain, let's see, what does it look like? It would only gain about 2,000 more trained workers versus with this more elastic demand, we're able to gain up to up to the socially optimum output of 35,000 workers. So the shape or the elasticity of demand matters. And that pretty much does it for your Chapter 15 homework. Okay.